Hey guys, Fred here, AF Math and Engineering. Today we're looking at integral substitution, so U substitution. We did a video previously on that using indefinite integrals. We were solving integrals with no bounds on them. And now we're going to show you about definite integrals, okay? And the main difference here is that when we make a substitution into a definite integral like this, okay, the bounds potentially are going to change, okay? We're gonna need to update the bounds using our substitution, all right? So that is the main trick here. And we're gonna go over just two questions and we're just gonna explain, or try to explain to you and get across the concepts. So let's go ahead and let's just get right into the first question. So it asks us to solve from 1 to 2 of x times root of x minus 1 dx. Perfect. So from the previous question, we kind of discussed what to substitute, all right? And what we're going to substitute here is going to be the inside of the bracket. So we're gonna look for the complicated part of the equation, and we're gonna try and substitute that out and see if that works first, okay? So let's go ahead and do that. So, like I said, we're going to rewrite this from 2 to 1 of x root u dx. And right up here, I'm going to say that u is equal to x minus 1, right? And always we're just gonna go ahead and differentiate that quickly. So we're going to say that du is equal to, well, derivative of x is just dx, okay? Or it's 1 times dx. Perfect. So what have we done here? Well, I'm going to show you another trick, and this here we can rewrite as u plus 1 equals x. All right, so that's important as well. You need to know this trick here. Okay, so you can rearrange this equation here and just isolate for x, and we can go ahead and substitute that in, because otherwise, as you can see, if we plug in dx here, we're just going to have du, and we're going to still be left with a function of two different variables here, or a product of two different variables, which we can't solve. So we do need to put the entire equation in terms of u, and this is another way of doing it here. So with that being said, let's go ahead and continue the question. So let's make our substitution here for x. Let's go ahead and put that in, and we'll make our substitution for dx. So coming down here, we have u plus 1 is equal to x times root u and du. All right, so we're moving along. We have the entire expression in terms of u, so that's a good thing. However, these bounds are possibly incorrect, okay, because we've changed what the expression is and what the function is. So now we're going to need to change the bounds accordingly. And well, how do you do that? It's actually pretty simple. You just need to take these bounds and plug them into this equation for x, and then replace them with whatever you get for u. So let's do that with 2 first. So let's plug 2 in for x, okay, and 2 minus 1 is 1. So that's going to be our new upper bound. Perfect. Let's plug in this one into u, so 1 minus 1 is equal to 0, and that's our lower bound. It's as simple as that. Rewriting this equation here. All right, now, with that done, we've put the whole thing in terms of u, we've changed our bounds, and now all that's left to do for this question is to integrate if possible, and of course it is. We know how to integrate polynomial functions, right, using the power rule. We've discussed that in an earlier video. So what we're going to do is just multiply this root u into the equation. So we have from 0 to 1, and so this is to the power of 1/2, and this is to the power of 1, right? So we're going to add the exponents together, and that will give us u to the 3 over 2. And we have root u times 1, which is just root u, so that's going to be u to the 1/2. Perfect. So, well, how do we integrate this? We're going to use the power rule. I'm just going to come up here. And we are going to add 1 to the exponent and then divide the whole thing. So, let's go ahead and do that now. We have u to the 3 over 2 plus 1, okay, is going to be 5 over 2. 5 over 2. Okay, and we're going to divide the whole thing by 5 over 2, and I'm just going to show you the shortcut. So instead of dividing by 5 over 2, we can just multiply by 2 over 5, okay? So find the reciprocal of the fraction and just multiply it. That's a much faster way of doing it. Okay, and we'll leave that in brackets. And the next term is going to be u to the 3 over 2, right? 1 over half plus 1 is 3 over 2 times the reciprocal, which is 2 over 3. Perfect, and that is all evaluated from 1 to 0. All right, so go ahead and apply these numbers in. I'll let you do that on your own, okay? That's good practice. Apply these bounds, right? So plug in 1 and then subtracting, plugging in 0, right? And you know, this one isn't actually too hard, but we should be left with 2 over 5 plus 2 over 3. And adding those two fractions together, we're going to get 16 over 15, which is our final answer. All right, so I hope that introduced you to changing the bounds in a definite integral substitution scenario. So let's do something a little trickier in the second question. So we have solve from e to the fourth of 1 over x times root of ln x dx. Okay, so this looks a little bit confusing, right? This looks scary. What would you substitute here? You know, what would you substitute for u in this question? Pause the video and just take a guess. And if you don't want to pause it, that's fine. Let's just start solving it. So what we're going to substitute here is ln x. Okay, so we're going to take the kind of the complicated part of the function. Usually it's inside of a root or in a bracket, and it's it's more than one expression, or more than one function. But in this case, it's just ln x. Okay, so there. So let's go ahead and so we're going to substitute ln x here. We're going to say that u is equal to ln x. Perfect. And if you'll remember from the integral section, or even from the derivative section that we did, we know that the derivative of ln x is 1 over x. Okay, so du is equal to 1 over x dx. All right, and so let's go ahead and bring this down here. And we'll just start writing it out. So we have dx over x root u. All right, so what do we need to do here to continue? We need to somehow get rid of this x, and we need to get rid of the dx. So we need to get the whole thing in terms of u, right? Which is what we've been discussing. And I think I know how to do that. And I'm seeing a pattern here, and you will see patterns in these substitution questions, is if we go ahead and solve for dx here, by multiplying both sides by x, we should be left with du times x, right? Let's just move this x to the other side. All right, and let's plug in dx here, and we should be left with e to the fourth over e, and then we have x du over x root u, right? And as we can see, the x's cancel, okay? So just that's one of the tricks that you guys need to look for. Now, what's the next step? Well, it's the same step as we followed in the first question, right? We've put the whole thing in terms of u, and now we just need to modify our bounds to fit our new expression, our new function. And we're going to take these bounds and we're going to plug them into our u equation here. We're going to see what we get, and we're just going to replace these bounds here. So, well, what's e to the fourth if we plug it in here? We have u equals ln e to the fourth. So ln e is just 1, right? And then that is going to just equal 4, all right? So the top bound is now 4, and if we plug in e for x here, all right, so if we say u is equal to ln e, okay, that's just going to be equal to 1. All right, so now we've modified our bounds. We have from 1 to 4 now instead of e to the fourth. So we have 1 to 4 of du over root u, and as we discussed before, that's a fairly simple power rule question that we're going to evaluate. And let's go ahead and do it. So let's bring the u up to the top, all right, and make the exponent negative. So we're going to end up with u to the negative 1/2, all right, and adding 1 to 1/2 is going to just give us 1/2, okay. So I'm just going to, go ahead and skip that because that's a fairly simple step. So we're left with u to the 1/2, okay, and we're going to multiply by the reciprocal of this fraction times 2, all right, and just move that 2 outside of the bracket. As we do with integrals, we just take the constants and move them out, and that is evaluated from 1 to 4. All right, let's go ahead and evaluate that. So we have 4 to the power of 1/2, right? Minus 1 to the power of 1/2. All right, and as we know, the power to the power of 1/2 is just a root. And what does that leave us with? That leaves us with 2 minus 1. And 2 times 1, which is equal to 2. That's it, that's the question, guys. So we're done 2 questions. We have learned how to change the bounds in a definite integral substitution question. Hope you enjoyed that one. It's, like I said before, it's all practice, guys. You just need to learn all the tricks in your book and look for little tricks that they like to use, because you can almost guarantee that those are gonna show up on your exam. And you know, if you know the tricks, this stuff is easy and you get 100%. Thanks for watching, guys, and as always, like and subscribe if you enjoyed the video.